Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video, we continue looking at sorts, and in particular, we're going to look at the selection sort. In the last video, we looked at bubble sort, and we said that bubble sort, while it was a sort that people liked to write a lot because it was so easy, it was very much something that humans wouldn't actually do because in some ways it was inefficient. It winds up moving stuff around a lot more than you necessarily need to, and that's what humans would really avoid doing. The selection sort is actually a lot closer to what you might really do. So if we go, and let's go ahead and bring back in the array that we started with the first time, and I want to sort this array using a selection sort. Now the way that selection sort works is, and selection sort can be written as a min sort or as a max sort, or technically as a min and max sort. What I'm going to do is I'm going to run through this array and I'm going to look for the item that is the largest. Or sorry, I'm going to go with the min sort, so I'm going to go with the smallest. So the way this works is I have a loop and I remember the smallest thing that I've seen so far. So I'm going to start off saying, okay, well this 5 is the smallest thing I've seen so far. And I'll remember that. And then I look at the 8, 8's not smaller than the 5. So I forget about the 8, I go on to the 3. The 3 is smaller than the 5, so I forget about the 5 and I remember the 3. The 2 is smaller than the 3, so I forget about the 3 and I remember the 2. The 9 is not smaller, the 6 is not smaller, the 4 is not smaller, the 7 is not smaller, but the 1 is smaller, so I forget about the 2 and I remember the 1. And then, after I've decided this is the smallest one, I'm going to swap it into place. This is something that I try to go over many times with my students. The selection sort swaps the item into place. It does not shift things around. Shifting things around would be very inefficient here. So instead, it takes this item and it moves it into our temporary space, and then it takes this item, moves it to where the 1 had been, and then puts the 1 back up here. So now the smallest element is in place. And then we repeat the same thing again. We're going to go through and look for the smallest element. We wind up finding it. It's the 2. So now I'm going to take the 2 and swap it with the 8. Now I run through and I find the smallest element again. It's the 3. It's already in the right place, so I don't have to do anything. Then I run through and I find the smallest thing. And note that each time I'm ignoring all the stuff that I have put into sorted order at the beginning. So for here, I'm only looking at the last 6 elements, and I'm ignoring the first 3. I find that the 4 is the smallest, so I take the 4 and I move it down, and then the 8 swaps over, and the 4 comes up. As I said, this is actually a sort that you might really do. Okay? If I gave you a bunch of file folders, while you probably wouldn't be extremely methodical about doing exactly a min sort, which is what I'm doing here, you might come close to it. You might actually go through and look and find the smallest element, and then take that element and move it to the front, or maybe put it off in a separate pile. So after we swap the 7 and the 8, we look, the 8 is the smallest, it's in the right place, and at that point we stop. There's no need to check for the 9 because it's the last thing and everything else is in the right place, so it has to be in the right place as well. So that illustrates the usage of the selection sort. Now let's look at what the code for this would look like. So let's go back into our sorts. And I'm going to write a min sort. It is going to take an array of double. And just like our bubble sort, it doesn't return anything, it just alters the array. So, also like the bubble sort, this sort has basically 2 loops to it. And first I'm going to write them as nested loops so that you can see that, and then we'll probably modify it to use a single loop with multiple generators in it instead. So our outer loop basically specifies how many times this happens, And in some ways you can picture it as being the question of where is the item that we are, where is the location that we want to swap our next item into. So when I went through and I found the 1, I swapped it to index 0. And then I went through and I found the 2 and I swapped it to index 1. And so that's exactly what I want to do here, is I want to go from 0 until arr.length minus 1. And that minus 1 is in there again because after I have put in minus 1 elements and there's only one element left, if all the others are in the right place, it has to be in the right place as well. Now the next thing that I do in here is I am going to run through all the elements and I need to find the minimum. And I kind of tried to illustrate the fact that part of what this requires is finding I have to keep track of the smallest thing that I've seen so far. And so I'm going to create a variable min, and I want to set it to be I plus 1. Actually, no, let's set it to be I, sorry. So I'm going to swap whatever it is into the ith position, and I'm just going to assume to start off with that the thing at the ith position is the smallest thing I've seen. If it's the only thing I've seen, it's the smallest thing I've seen. And so then I have a for loop where j goes from I plus 1 until arr.length. And inside of here, I want to check. And I want to say if arr sub j happens to be less than arr sub min, well, then I need to change min. I've just found something that was smaller than what I thought was my minimum. So that index, the index of this new thing, becomes the smallest one. That's all that this inner loop does here. It does a comparison and it assigns this variable. It doesn't actually change the array in any way, shape, or form. And that's a bit different than the bubble sort, where inside of this inner loop we had the ability to change the array. We come down here to the end. If min is not equal to I, then I want to actually do my swap. Val temp equals arr sub, and here I am swapping the location at I with the location at min. Okay, so it's basically the same 3 lines of code that we had up here. These 3 lines of code swapped what was at location j with what was at location j plus 1. These 3 lines swap what's at location I with what's at location min. So I can come down here and test it out. Make a call to min sort instead of bubble sort. And if I run this, so we start off, once again we have random values, they're not in any particular order. 0.04, 0.17, 1763, 1764, 0.23, 0.26, 0.268, 0.273, boom, 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 all the way up to the end. Yes, they are all in order. So we have a functioning min sort here. Now this isn't technically a very exhaustive test. We didn't verify that it works on really big arrays. We just verified that it works on this little array with 20 elements. We'll revisit that, how we could make sure that these things actually work a little bit better, do more exhaustive testing. You can probably see just from looking at this code that indeed one of the reasons why we like the bubble sort is because of its simplicity. Now right now it's gaining a little bit of an advantage because I haven't condensed this down to a single for loop with multiple generators. Actually, in fact, now that I look at it, I can't in this case, can I? It worked really nicely for the last one, but because this, so if all of this could be put in with the multiple generators, but this is only inside of the outer loop. It's not inside of the inner loop, so that causes us a problem. We have to leave it in this form. Now, once again, min sort has a certain advantage over bubble sort. It is actually something that you would consider doing with items. In fact, if you were moving cars in a parking lot, you would almost certainly do a min sort. And the reason is basically because the swap here is not in the inner loop. Okay? This swapping, the whole, pull a car out, put it in the temporary spot, move a car over, pull the car from the temporary spot back into the main line, that whole bit of work, that's something that takes a lot of time, and this sort only has to do that order n times. Okay? It might do it fewer, so the most it's ever going to do it is n minus 1 times. It's going to do n minus 1 swaps, worst case. But in better cases, it will find things at the minimum location several times. We actually had that happen in our example that we sorted. So this is a sort that in some ways it minimizes how much you move things around in the array. It turns out that's not hugely significant for Scala when we're sorting arrays in memory, but there are situations where it can be significant, and in those situations the selection sort really can be advantageous. Technically, it does just as many comparisons as the bubble sort. The comparison here happens exactly as many times as the comparison here. So you don't get an advantage in that. And so if your comparison function were expensive, then min sort and bubble sort would effectively take the same amount of time. However, if your memory moves are expensive, if moving things around in your array is expensive, then the min sort is going to do a much better job than the bubble sort generally. So that's it for this video. We'll come